Good morning, good afternoon, good evening, whatever time of day you're watching this. Charlie and I are out and about today. We're on our way into London town. Got a few things to look at, so we'll get as much of this as we can on video. So on this job, I decided to do a voiceover because the client was in the house, as myself and Charlie, and the loss adjusters wanted to bring their own surveyors in as well, so there was two of them. So this relates to a storm damage claim where water actually flowed out of the subfloor vents. The initial survey report that was provided by the insurer's surveyor said there was no ventilation to the front of the property, no ventilation to the rear. But as soon as we visited, we can see that there's actually quite good levels of subfloor void ventilation, and we'll come back to that in a minute. But before we go cutting into the floor, one thing we want to do is drill some small holes so we can check hygrometer readings. It's much more accurate if we do these through small holes before we start lifting the floor, because ultimately if we cut 4 or 5 big holes in the floor, the air in that floor void will want to reach equilibrium with the moisture content of the air in the house. Completely understandable. So we do this first by drilling some small holes. So we can see in these readings here that we've got elevated relative humidity readings, over 85% is just there. And we've also got elevated actual humidity readings in excess of 10 grams per cubic meter, which we would consider to be high. Moving on, we've then opened up the floor in a couple of locations, and we can see here we've got the inside of our periscopic vents. Again, we've ended up having an argument about these because the insurers believe they're not acceptable. We say they are, so it's just a case that we would argue our point on this. Periscopic vents are used on all new housing where you've got suspended floors. When you're forcing air, such as mechanical extraction, it becomes quite important that that air is flowing along a smoother pipe as possible. When you're dealing with mechanically extracted air, so air that's forced, it's important that that air flows down a smooth, straight line as possible, because you're forcing the air. Every time you add a junction, so every time you add a bend, that the flow rate becomes less. That's not the same when you've got passive air vents such as this, so any idea that they won't perform as well is not particularly true. What we can see here is high moisture readings in the timber floor joists. Anytime a softwood timber is in excess of 20% moisture content, there's a good chance of rot occurring over the longer term, so it's something that needs to be addressed. So quite an interesting one, this one, because the property's been built acceptably, no real issues with the house at all. But what we do have, this is in Walthamstow, and large areas of Walthamstow do flood, suffer from surface water flooding, and this is one of those. So it's actually been with the torrential and prolonged heavy rain we've had over the winter this year, it's caused the ground levels, the groundwater table to rise and cause basically surface water flooding that's come up from the ground. So something a little bit different on this one. So we're now back into the car and onto the next inspection. Work in progress on a fire damage reinstatement project. Blockwork's been reconstructed around the property because it was so badly damaged. New wall plates being put in. Wall plate straps are evident in some locations, not just there. This has still got to have its wall plate straps popped in. Actually, over the other side they've been fitted there somehow, not to this side. So here we've got existing blockwork on this bit, a new 75 by 100 wall plate, then it's got a 25 by 100 extra plate fitted to the top of that. So I should imagine that's just to get the heights ready for the ceilings inside. You can see here, the truss will be sitting on there, on that side. It's 600mm sitting in line with there on that side. But in our main roof, the trusses will be lined up 600 centres that way. So this was a little extension that was built originally to the house. Sorry, extension was built onto the original house, and you can see the extension joint there. So here we have the original mineral quilt insulation that's been put in the cavity, and there is the original house. We've had to rebuild it, so something's got to be done with the insulation in the cavity because it's not at the moment wide enough to be filled on its own. See on this elevation here, from the brickwork it looks a bit different actually. So it's almost like we've got an orange brickwork up to here, yellow above. Doesn't matter, it's just the way things are sometimes. So we can walk around the whole of the top floor on the scaffolding. Here's one of our plates, one of our ties to the plate. And again, all the trusses are marked out, fit on that line on that side. Got some materials on the site. This is diagonal longitudinal bracing for the trusses. And then here, some of the trusses are on site. These are for the smaller trusses going over the side extension. And the main trusses are downstairs, so we'll just go and see what materials are downstairs. We'll be asking the builders to tidy up because it's a bit shabby. And then around the front, loads of materials are just being dumped on the scaffolding, so that all needs to be cleaned off. When we did one of our original inspections here, there was the remains of a garage, and that's next door's house, also with a tin hat, because they've also suffered quite significant damage. So this particular job, I think we can say now, I don't think there's any issues with it, but the fire started on an outside boiler, which then the pipe to the boiler melted, dripped down, and next door's garden there, just in there, you've got the plastic oil tank, and that set fire to the garage, which then turned around and set fire to the house and set fire to next door's house. So it's a big chain of events that's caused quite catastrophic damage. The oil tank next door needs to change position because it needs to be at least 2 meters from a house and at least 750 from a boundary. At the moment it's right up to a boundary and only 1 meter or so from the house. So we just going to look downstairs now. So the trusses for our job have been actually put in next door's driveway, which I guess is not an issue because they're having works done as well. These are finger style trusses, probably the most common type of truss there is. And the wall plates we spoke about upstairs will sit right down, just on that point there, just below that gangnail plate. And then we've got overhang, which is over the cavity wall and the soffits. There's some tile battens here ready to go up, but I'm going to need quite a few more than that, and some crap that's come out of the house from the fire. And then as part of the truss delivery, we've also got these fellas here, which are called gable ladders. So the cavity wall, gable wall, will be there. So these are in kind of wrong orientation. I don't want to flip my phone because it'll go funny. So these actually bridge over the cavity wall. So the barge boards on the ends will be fitted to the outside there, and these will just be nailed to the last truss, which will be inside the property. So at the moment, one of the issues is how to get the trusses up when you've got all this here. So they're not huge, but they still need a space. So scaffolders are coming tomorrow to do some alterations so the trusses can be lifted up, and then they can get cracking with the roof. And as soon as that's felt and battened in, this temporary scaffold lid can come down. Around the side of the house, we had to do a little bridging area of the scaffold here, which is why we've got this truss ladder arrangement to give us about 4 or 5 meters between the standards. It's because the oil tank was here, and there was a fear that this area here would need to be all broken up and excavated out to deal with any ground contamination works. But it doesn't look like that's been done, so it might have been a waste of time, or they're just not got around to doing it yet, so we need to find that out. This is the oil tank for our house. It's a metal oil tank, a bit better than a plastic one, but even that's too close to the property. And then we've got some scaffolding materials on the site, and that's our house viewed from the rear with the full tin hat in situ. Bit of a whistle stop tour around, not a massive amount to see at the moment, so we'll try and get another video when we're back another day.